All right, let's go ahead and get started. So hello everybody and welcome to today's webinar presentation, Snowflake Data Apps Demo, Auto-ingest streaming data from Twitter with Snowpipe, brought to you by Snowflake. I would like to introduce you to our presenter today, Daniel Myers. Daniel leads developer relations at Snowflake. He has held leadership roles in product development, engineering, product marketing, and business management from startups like Livewire Hosting and PetroCloud to Fortune 500 companies like Google, Cisco, and Fujitsu. Daniel is an inventor of 3 patents and has a bachelor's degree in computer engineering plus an MBA from the University of Texas at Dallas. At this time, I'd like to pass it over to Daniel for the presentation.
Hey, thanks. Like was said, my name is Daniel Myers, Developer Relations here at Snowflake. Today, I'm going to be going over a demonstration of Snowflake itself, and more specifically, how you can use Snowpipe to automatically ingest streaming data like Twitter data directly into Snowflake and visualize that data using a dashboarding tool like Tableau. Let's get started. So the first thing that we need to have a common level understanding of is Snowflake's broader platform. Now, Snowflake is more than just a database. You've probably heard the term the data cloud, and that's truly what Snowflake is today. It allows you and enables you to utilize any of your data sources, whether it's third-party web log data, IoT data, OLTP, OLAP data, any of these data sources can be ingested, streamed, and utilized onto the Snowflake platform. Now, there's 6 main workloads that we target today. That's data warehouse, data lake, data engineering, data exchange, so that's like sharing data and things like that, data applications, and data science. All of these things run across all 3 major cloud providers, GCP, AWS, and Azure. The key aspect here is that with a data cloud, you are able to connect all of these pieces together in a unified way so that all of your data consumers have just one location where they need to get that data from. So whether it's to operationalize and report on that data, ad hoc analysis by data engineers, or real-time analytics directly embedded inside your application, which today we're going to be focusing on data application workloads. And so there's a few key things to understand about the architecture behind Snowflake that makes that data cloud work. So there's 4 main layers here. As I said before, there's the cloud agnostic layer where Snowflake is able to run using the native resources of each cloud provider, GCP, AWS, or Azure. Now, the next layer up is cloud storage. This is where you are able to actually independently scale with compute the next layer up between those 2 aspects, right? With legacy databases or legacy cloud storages, you won't be able to scale that in the same manner. And so when you can scale compute and storage independently, it really enables you to have a different kind of use case. For example, you can actually have compute that's dedicated to a specific team or a specific project or even a specific application. This means that you won't have queries that are competing for resources when you're trying to, at the same time, ingest more data. And so the 4th layer on the top there is really those cloud services layer. That's where you have transactions, the security and governance aspects, all the metadata that really enables the workloads to operationalize across each other. The sharing, collaboration, and user management, things like that. Even query optimization lives within the cloud services layer. Now, it's important to know some of the common use cases that run across data apps. So for example, Customer 360. That's the idea of knowing the customers that are coming to either to your application or to your store, things like that. Internet of Things, right? Where you have sensors everywhere and we're streaming those events into Snowflake and we're able to analyze those events and do some type of action based on those events. Machine learning and data science, right? App health and security analytics. App health is an interesting one. So that's everything from the security that's going on behind the network of your application to different streaming events of clicks, for example, on a website or your mobile app, to embedded analytics, which is the idea of embedding a dashboard of some kind directly into your application that's run by Snowflake. Pretty cool. So the next really great aspect about Snowflake and for data app workloads is that you have a wide variety of different drivers based on the environment that you're developing your application in. Whether or not it's JavaScript, Node.js, .NET, Go, Java, Python, etc. There's a ever-growing ecosystem of first-party drivers that Snowflake directly develops ourselves, as well as third-party inclusions into other frameworks, right? So that's going to be really awesome to see as that continues to grow and get bigger. Now, some of the key features that are specific to data apps and how it's so useful is, first and foremost, semi-structured data, right? This allows you to natively query directly in SQL things like JSON or XML, Avro. And it utilizes a variant column name, right? So what this means is that you can have a single SQL statement that can get a particular element within a JSON document. So pretty cool stuff. Next is zero copy cloning. This is a really powerful feature because what this enables developers to be able to do is have essentially a logical clone of your data. This means that it's not actually cloning the data on disk, but instead you're able to have another logical clone of it. So you can have one for prod and one for dev, where it's actually looking at the same underlying bit of code, bit of storage on disk. And what this enables that to do is that there's no periodic refreshes from prod to dev. If you're trying to do some type of testing on things, it literally reduces by half the amount of storage required to copy those things, right? There's only one actual storage element, so there's no actual cloning involved, zero copy. So it's a really powerful feature specifically for developers. Time travel. This is one of my favorites in that this is a lifesaver when you, for example, maybe accidentally drop a table. You can actually query the database literally, quote, as of a specific time. What this means is that it's not just for accidental deletions, but if you're looking to have versions of data, you can do that now directly within the Snowflake Data Cloud. All of this is via SQL extensions. So again, that's the key element here that you'll see a common theme within Snowflake is that everything, all actions that you do can be done in SQL. Really awesome. Adaptive caching. So what this enables you to do is have really fast access to query planning. This is done automatically for you, and there's not a whole lot that you need to do really for this. So this is one of those things where it really reduces the amount of management required to run your data application on something like Snowflake. Extensibility. So external functions is one of the most powerful features on Snowflake today. This allows you to directly call things like Lambda functions or GCP cloud functions directly from a SQL query, for example. And so you can have event streaming that's happening, calling an external function, for example, to translate some text, right? So it takes some text from the database, it gives it off to this external function. The external function then returns the translated version, and you're able to save that in another table or update to the existing table, etc. This now starts to get where you have event-based things happening directly from your database, calling all of these external functions across any cloud provider. Really awesome. Snowpipe. This is one that we're going to be going over today, and this is what allows and enables you to have automatic ingestion of data as it comes in. So you just configure it once. It's all event-based, so as new data comes in, it's automatically grabbing that data automatically loading it into Snowflake and making it accessible to any user on Snowflake that can query it. So pretty cool stuff. So automated ETL, Internet of Things is a really big use case here. We're going to be using this to automatically ingest those tweets today. So we'll see that here soon. And so, the other really cool thing actually about Snowpipe is that the credits used to do it can be very low because it's automatic. You don't have to have a dedicated compute resource that is just on all the time listening. Snowpipe does that for you. So the Snowflake Data Marketplace, this is another very powerful feature of Snowflake in that you have direct instantaneous access to a lot of different data providers. So everything from COVID-19 data sets to weather data sets, you can search all the various categories on the marketplace. And what's cool about this is that you can get tailored data from these data providers. The data itself is natively shared on Snowflake, meaning that when the data is updated, you're querying it just as if it was another table on your database already. And it's all completely managed by that provider. So it's really powerful and enables you to get instantaneous access to updates as well, because those are, again, just you're querying it just as if it's another table on your database. And it's all available on the marketplace today. So the other thing is geospatial support, right? So as you're building an application, there's a lot of times where you need to have specific locations of queries, right? So somebody from Dallas, Texas might be looking for a place to eat, right? And you want to be able to search within a certain distance or intersections and things like that, or a containment within a certain field in Geospace. So you can do all of that natively on Snowflake today. Really awesome. So the key aspects here today that this demo will show you is data loading. So specifically, like I said, Snowpipe. We're going to be using Snowpipe to load Twitter data. We're going to be showing semi-structured data. So all of this data that's coming in from Twitter is all in JSON. So we're going to be loading this JSON data raw directly into Snowflake. And then we'll be using secure views to allow data analysts to query that data. Pretty cool. So the overview of kind of how this architecture takes place is I have my machine here that I'm going to be grabbing all of this Twitter data from. I have a Python application that's running in a Docker container. And this Docker container Python application is listening for new tweets from Twitter. As it's grabbing those new tweets, it's going to be saving a small file. It's going to get 100 of them at a time. And each 100 tweets, it's going to upload it to Amazon S3, where then Snowpipe is listening for S3 events. Hey, boom, a new file just was uploaded, and it starts to download that JSON, that large document file, and ingests it directly into a tweets table. And then we're going to be creating that view, that tweets BI view, and to structure this semi-structured JSON data. And we're going to be doing that within a tweets warehouse. And then I'll show you also how you can view and visualize some of this data directly in Tableau. So let's go to the demo. What we have is my Snowflake instance running. I have my storage. I'm going to be creating the warehouse. So let's run these one by one. So I use the role sysadmin. Now I'm going to create and replace the warehouse. So this is the query to do that. The next, I need to actually create the database where I'm going to be storing all of these tweets. And next, I create that stage. Now, what is the stage that you ask that I'm telling you about? That is the piece here where I am uploading the files directly into S3. The stage is what Snowflake uses for ingesting it. Now, for those of you that notice, hey, Daniel, you have your secret key here. Rest assured, by the time you see this key has already been deleted. And so the next piece that I have to do is create a table within my database. And you'll notice here the key element within this command query is the variant column type. And next I create the pipe. Now this is where it's actually going in. It's copying into the tweets table that I just created here. It is copying it from here into my table. And now what I'll do is I'll go ahead and show the pipes running. And so I've previously already ran all of this, and so you already see the name tweet pipe, database name Twitter DB, and here's the definition of my pipe. And so with that, what I can do now is I can start to view some of this data. Now, before I do that, though, I need to start up my Docker container that's actually going to be live streaming these tweets. So what I have here is a Docker container that's running a Python application. That is, when I click this, it's looking for and searching for a very specific hashtag, COVID-19. And what I'm doing here is every one dot represents 2 tweets. And once it gathers up 100 tweets, it's going to upload this single Twitter file into that S3 bucket, and everything will get kicked off at that point. So let's go here and start viewing some of the tweets that I've already set up in here. So I set up my various context. I use my schema. Now let's go ahead and list out some of the tweet files that I've already uploaded. You'll notice that each of these S3 bucket JSON file has been uploaded. Looks like I have 20 of them, so it represents about 2,000 tweets in total. And so let's actually select one of these and view them. So you'll notice here I can do that. Click on this, and I can actually view some of the JSON data within these files, right? And so this is what it looks like. Lot of information in these in each JSON object. So let's take a look and view my pipes again. From here, I can still see my tweet pipe is running. Has been created, I should say. And let's actually look at the status of this. So you can see here that it's actually running. There's no pending files, so all 20 of those files that I showed you earlier have already been processed. That's great. So when I look at the contents of the tweets table, let's look at that. So you can see here a total count of 2,000. Awesome. Let's look at the actual contents from the tweets table itself. You can see here each tweet variant column type. I can click on that and view the JSON data again. And now what we're going to do is this is really where the magic happens, because what we want is to be able to have Tableau view and visualize this data, this JSON data. The way we're going to be doing that here is I'm going to be creating a secure view called Tweets BI, and I'm going to be selecting particular elements within that JSON object and assigning it to a column within Snowflake. And so you'll see here, I actually have even the type, so timestamp, string, int, there's even a Boolean in here. I can assign each of these a column, and that way Tableau can query it just like any other SQL database and be able to visualize that data. And so when I do that, I can run and see how many rows there are inside of that view. And now I can actually view the structured format of that JSON data. So you can see here I have some previous queries that I've done. So Lakers, scroll down a little bit, and I can see some more different types of data. And from here I can see, everything from user description, you screen name, how many times it's favorited, user profile links, etc. So pretty cool stuff. And what I want to be able to do now is if I go to my Tableau dashboard, you can see some of these tweets running in this dashboard here. So I can actually see Twitter for Android is the #1 client for Twitter. I can also see just a raw list of some of the tweets coming out. What's interesting to me is that a lot of the tweets that are actually created are simply retweets, right? So it's literally Twitter is in some regard a literal echo chamber. So that's interesting. And so from here, right? So I've shown you now how to create the stage for how to create the stage for importing these tweets. I've shown you how to pinpoint and view the unstructured, semi-structured JSON data, how to query that data, and how to create a view of that semi-structured data for Tableau. And so let's go back. Awesome. So how can we today download the source code of this demo? Well, it's good. It's available right now on Snowflake Labs on GitHub. So you can do it, view it right here on this link there. You will need a Snowflake account to run this demo. So you can get that account today at trial.snowflake.com for free. You also will need a Twitter developer account to get those live tweets coming in. So you can sign up for a Twitter developer account at developer.twitter.com as well. Now, what's really exciting about a lot of this is that we have so many companies developing data applications with Snowflake today. Everything, from Instacart, Okta, SendGrid, you name it, and they're working with Snowflake. So it's really, really interesting to see, really exciting. And I think it really shows the power that Snowflake can provide a lot of these data applications. So, we even have a broader look here from data integration, ML data science, security governance, all of these different types of ecosystem partners that you can leverage when working with your data application on top of Snowflake. So really powerful and ever-growing ecosystem of partners and applications. So what's next from here, right? Well, you can learn more at developers.snowflake.com. There you'll see a whole lot of different resources that you can download, that you can read up on. You also, like I said, you can get a free Snowflake trial at trial.snowflake.com. And be sure and join your local Snowflake user group, right? You can meet other Snowflake builders, developers, and even other Snowflake experts, right? You'll even get to check out some of our data heroes, which are it's a specific program here at Snowflake where you can actually gather points based on all the various things that you're doing, and it's a really awesome community of people on community.snowflake.com. And last is check out this demo on github.com/Snowflake Labs. You'll also find on there a whole lot of other demonstrations and examples that you can download and play with on your own environment. So with that, I want to say thank you. My name is Daniel Myers, Developer Relations here at Snowflake. So questions are live now. Let's go.
Okay, as Daniel said, we will start the Q&A session of our presentation. At this time, I'm going to pass it back to Daniel for him to answer all of your questions that you may have. Again, please post those into the questions panel so he can get to them.
Yeah, absolutely. Thank you very much for that. So first off is, if anybody is, like I said, looking for that source code for this demo today, that has everything from that Python application that is listening for those tweets to all of the SQL statements that I'm showing here, all of that is available on Snowflake Labs on GitHub. So definitely go check that out. That's going to be really great. So let's see. One question that we're getting is, what is going to be the difference between ETL and ELT, and what's the best practice that one should follow if they're using Snowflake? So the answer here really is, the difference is where in your pipeline your data transforms are being done. In the past, data transforms would need to be completed before actually loading data into your database, primarily because legacy databases couldn't handle semi-structured data, like JSON, for example. However, with something like Snowflake, it actually truly supports natively semi-structured data, right? And even as of our November summit, just a couple weeks ago, we actually announced support for completely unstructured data, right? So now you can have your data science workloads actually running entirely within Snowflake's Data Cloud for things like images, videos, and do all the tagging that you need to do directly within Snowflake. But this means that you can have and load this raw data, JSON, directly into Snowflake and leverage SQL for your transformations, right? And that's kind of what I'm showing you today with creating that view, right? So we loaded JSON data, those tweets from Twitter. That's a completely proprietary model that they've created, that Twitter's created for each individual tweet. We load that raw data directly into Snowflake, and then we can query that JSON data using SQL. And that does really two things, right? When we do it in this way, where we load raw data directly into Snowflake first, and then do any transforms, if you even need transforms anymore. And that does several things. Is one, it reduces your overall operational complexity, right? No longer do you need a special transformation step before loading into your database, right? You can do those transformations in SQL. And doing it in SQL is what brings me to the next point there, which is you get all the performance optimizations that SQL provides out of the box, right? And so that's really, really powerful. And so another question that we're getting, does Snowpipe support other cloud providers, right? So I showed you today how you can use Snowpipe on Amazon AWS S3. Absolutely, Snowpipe does support all of the other major cloud providers, and S3, blob storage, GCP cloud storage. So that's really exciting. Let's see, another question that we're getting is, how should I split up my data for Snowpipe? That's a good question, because there's a few considerations here when utilizing a auto-ingest tool like Snowpipe, which is, so the underlying storage layer that Snowpipe is using, just like Snowflake itself, are all the blob storage services from the cloud provider. So, S3, Azure Blob Storage, or GCP Cloud Storage. And so a lot of the same principles apply for, how do you optimize data for download and upload on those cloud storage providers. So, in general rule of thumb is that to optimize both the parallelization of uploads or downloads, as well as the amount of download speed that you can achieve, is to have files roughly the size of about 100 megabytes. That's the general rule of thumb that I follow, and that we've seen also with a lot of customers, is about 100 megabytes. And there's a lot of tools out there actually that will help delineate your data into various sizes that you may need. So check those out as well. Now let's see. Some more questions. Looks like we're getting quite a few questions now. And so here's a question from a attendee here. How would you cluster the tweet table for performance, since it's a single variant table? That's a good question, and I think it's going to be dependent on the data there. The one really cool thing is that Snowflake doesn't use indexes, so a lot of the idea is that Snowflake is able to manage automatically for you a lot of the optimizations that you may need. And so I the clustering there ideally will be able to be handled automatically for you. And it's going to be very dependent on the type and the amount of like, is it multi-tenant type of scenarios where you may want to share a portion of the variant column table with other parties, for example. So I would take a look at that. So another question that we're looking here, what is the maximum size of internal stage files possible as opposed to S3 stage? So that is a really good question. I don't know off the top of my head what the maximum size for internal stage files are, but that's something that I can definitely take a look at and get that answer. Let's see. Is it possible to have manual control on Snowpipe? So yes, there is a Snowpipe API, and so you don't have to have Snowpipe listening for S3 events, for example. You can kick it off manually if you'd like. If you have certain specific optimizations that you want to be able to do on your own data in your own ingestion pipeline. So definitely check out the Snowpipe REST API that's available on inside of our docs. Here's another question: what tool was I using for the dashboard view? In this case, I was demonstrating Tableau as the dashboarding tool. But the beauty here is that you can leverage raw data, and then you can map that raw data using a view to any structured, table-looking structure. So you can use any real dashboarding tool out there. Snowflake provides its own internal snow site, which is currently, you can actually try that out as well. It's called Snowsite. And you can check all of this out getting that free trial, so at trial.snowflake.com. With that trial, you actually get $400 of trial account usage for free. So that's highly suggested that you guys check that out. So here's another question: do you have to transform the data to JSON before posting the data to Snowflake DB? Definitely not. You can post data however you want. You don't have to have it in a semi-structured format in order. So it doesn't have to be JSON in order for it to be ingested by Snowpipe or adjusted into Snowflake itself. It can be in a wide variety of different formats and different ways of ingestion there. Let's see. Can Snowflake or Snowpipe read from a RabbitMQ queue? So yes, at the end of the day, it's going to be around that pipeline that's created. So it really depends on the getting it set up on a stage, right? So as you are reading from RabbitMQ, at what stage in that cycle are you putting that data or each element into a stage, whether that be S3, GCP Cloud Storage, or Azure Blob Storage. Once it's there, Snowflake handles the rest, right? And so that's the beauty there is the only connecting piece that you would need for ingesting something from RabbitMQ would be just getting each of those elements into a stage. Let's see. A question is, will this be available? Will this recording be available? Yes. Shortly after this, we'll be posting the recording as well and sent out. So you can check this out, the entire recording, as you may need. Let's see. So was I using the cloud version or local version of Tableau? So it really works with both. It's not that you have to have one or the other. there's a native connector for Tableau for Snowflake, so you can leverage Tableau in both of those environments with Snowflake. Let's see. Yeah, so it looks like that's a lot of the questions that we've had so far. And so with that, I want to say thank you everybody for joining here today. And if we have any more questions, definitely reach out, and you can definitely try out the trial at Snowflake, trial.snowflake.com. My name is Daniel Myers. Run developer relations here at Snowflake, and thank you for joining today.
Awesome. Thank you, Daniel, again for your phenomenal presentation. DZone thanks you a bunch. DZone again would like to thank Snowflake for providing the audience with a great webinar. Lastly, thank you to all of our attendees today. We hope you learned something new that will help you in your developer career. Have a great day.